So one of the things we love, of course, about the direction that ASP.NET is going is the fact that we can build minimal APIs. We like that as developers and engineers because we're drawn towards simplicity. We like the idea of having something that is both easy to do and simple as far as maintaining our code base. And then, of course, we start thinking, well, we want to add another piece of functionality to our minimal API, and it gets a little bit bigger, right? We don't have a problem with controllers. We just really love things that are small. But then as we start adding best practices and security and logging and all the other things, we're like, wow, my minimal API is still pretty significant when it comes to code. The worst of it, though, Frank, is that what I'm writing is the same thing over and over again, right? It's the CRUD code of like create, read, update, and delete. That same code over and over again inside my Data API. And so let me just talk about for a moment, just from an architectural point of view, the way we would think about.
Did you want to show some slide?
Yeah, sure, you bet. Way we would think about the architecture of just a simple API. And so this is about as simple as you could get. I've added an API manager, and I've also added authentication. So if we wanted to make this super simple, your client would go directly to your API without authentication. But let's just go with probably what you would do in an enterprise scenario and why each of these components really matters to you. You know that you have a database that you want to interact with, right? And so we're going to do CRUD operations. We're going to insert records. We're going to update those records. We're going to delete those records. But no doubt we're going to select those records to show in our UI as well. And so the reason we have this data API layer in the first place is to make sure that we aren't beating up our database in a way that isn't appropriate. So the first way is just to abstract things away from the database so that we can project the data in a way that perhaps we have a data marketplace and we're selling our data as a clearinghouse. That's really important. And so an API allows us to leave our database alone, but still expose that data, projecting the columns the way that we want to, projecting only specific tables the way we want to, as well as adding predicates to our queries to make sure that they only receive certain data rows as well. So we can do that by adding a data API without having to make any change to our database. That's nice. However, when you really boil it all back down to it, and you're a .NET developer, Frank, that C# that you're writing is the same thing with every project. So I go in and I'm writing my controller, or I'm writing my minimal API, and I just copy it from my previous project because it's the same code over and over again, change the table name, update the field names, and go from there. And I suppose if you're paid by the hour, that's really appealing, right? Because you just get to do so much extra work. But the downside is the more code that you write, the more opportunity you have for either it to be out of date over time because something has changed, or the opportunity for you to introduce a bug. So to make sure that you don't have a regression or some type of bug in your code, naturally, we would just introduce unit tests against it to make sure that my API runs the way that I expect it to run. All of this is just code growth over and over again. The handful of lines of code that you had to build your client now has doubled, tripled, maybe sometimes, depending on how you want to write your API and how many objects you have. The repositories that you've built, the frameworks you've had to introduce, and all of it is the same as the project before and the project before that. And you find yourself doing some copy and paste inheritance of some of the bugs that you had from previous projects into this project as well. Wouldn't it be nice if we could just take this middle piece out, this API circle, and just remove it completely from our overall architecture and topology of our solution, and still have the same capability, still be able to do things against our database, project the data, as well as advanced features like caching and security, claims management, policies, and all the pieces like that without having to write it again. So that's the whole idea of why we talk about Data API Builder, because Data API Builder allows you basically to sidestep the problem, to look at it and say, listen, when I build the Data API, I build it awesome. And I build it with this feature and this feature and this feature and this feature, and so do we. This is a .NET engine that is implemented the way you would actually implement it, with all the exotic features and capabilities that you would expect, all container-based and cross-platform and language independent, where you don't have to introduce a brand new framework or anything else along the way. So that's really, really nice. And that's what I want to kind of talk about here. I want to just point out we have API Manager here. And the reason you have API Manager is because as soon as your API becomes significant, You need a manager to be able to make it so you can handle things like versioning or maybe even payload manipulation on the inbound and outbound, as well as advanced security that you might need depending on whatever your source of authentication is. All right, so that's at the highest level, and hopefully your solution looks something like this, right? You have your own components that you've added in other places, but at the highest level, those are the components. Now, Data API Builder gives us both a REST endpoint as well as a GraphQL endpoint, and we'll talk about the advantage of that today. And we'll talk about how REST is so easy and so common and so universal. We all know how to use it, built into the HTTP client, and calling it is such a straightforward thing, and we'll deal with that here in just a second. But we also support GraphQL. You don't have to, it's not a choice between one or the other, and we'll talk about why that is strategically valuable for a lot of UIs, a lot of clients, and even though you might still be using REST for a lot of the capabilities that you think about when you have a data API, at the same time, a more advanced data API might find value in a GraphQL. And we'll talk about that here in just a second. Data API Builder is really built for Azure databases. So we have SQL Server, of course, Azure SQL DB. We have Postgres, we have CosmosDB, as well as MySQL, all hosted inside Azure. But if you want to be on-prem and you don't want to deal with Azure, or you want to host this in another competing cloud, that's totally fine. Data API Builder is completely open source, and you can use it however it is that you need to use it. In fact, it's not just one or the other. If you have multiple of these databases, you can have Data API Builder point to many of these simultaneously. So you don't have to choose between one or the other, cloud, not the cloud, whatever it is that suits you guys, and whatever it is that your solution is already using. You don't have to go and negotiate for a different set of technologies. You can just use it right where you are. You can have a plan perhaps to upgrade and know that Data API Builder will handle that upgrade for you as well. So that's really nice to know that the backend database is so flexible as well. All right, so let me show you something really cool. I can't get away from the fact that I love Star Trek as much as I do. So our database remains the Star Trek database, and it's really easy. And it's really great because it shows us all the different types of relationships and table types, and as well as data types to interact with as well. But we're going to do something very straightforward today and just try and list the series. So I'm thinking of all of the original series, the next generation, and things along those lines, right? So all of you who thought it was going to be The Force Awakens, that's the wrong franchise. We're talking about Star Trek. And so this is the table, nice and simple. It is the series table. And I want to show you the basics of creating the configuration file to set up a Data API Builder instance. So remember, it's container-based. This is not code generation. Not at all. It's not a framework or a NuGet package that you interact with in your code base. No, this is simply a container that you drop into your overall topology so that you can have that as your data API on top of your database. Then to configure that, you provide it a JSON file, the end. That's all that you provide it. And let me show you what that looks like. So I have let's see, right here, I have a simple example that I just want to show you how you would start with in fact, I have this right here. All right, so it's a command file called Star Trek, and it just shows you the two commands that you would use when you're starting to build it from scratch. So I want to just show you as little as possible so that you can really see that just getting off the ground and having a data API is ready right off the go. And so if you want to run this in Docker, if you want DAB CLI to host this so you don't even have to have a container manager like Docker, fine, no problem. You can use the DAB CLI to do that. And then where you deploy it is going to be up to you. Static Web Apps is something we showed earlier, but now you can also do it in ACA, Azure Container Apps, or ACI, Azure Container Instances, or AKS, Azure Kubernetes Services. And so look at this. So the first command is dab init. This initializes the configuration file for you, tells you that it's going to be a SQL Server, and it also says what the connection string is. So in this case, I'm using an environment variable called my connection string, and then I'm saying that this is going to be a development environment so that I can have extra developer capabilities like Swagger, and we'll see in just a second, we'll have Banana Cake Pop. And so I'll add a single table. Remember, that's the series table. And so I'll add the series table. Here I'll say the source is dbo.series. That's just the schema plus the object name as well. It could be a table, could be a view, could be a store procedure, and it could be a container in the case of using CosmosDB. But this is SQL Server, and we have to set up what the default permission. So in this case, of course, we make it as simple as possible with anonymous star. So star means all of CRUD is available, right? The read, create, update, and delete are all available. I could individually add access to each of those depending on how I want it, but it's as simple as possible. Now when I run it, it runs the command, and I want to show you the resulting piece here. So inside my one folder here, I have the configuration file that was created. It's really, well, let me scroll to the bottom just to show that it's 60 lines. Each one of those lines, then I only ran 2 command lines in the CLI, but it built all of this JSON, and it's a little bit tricky sometimes to get JSON right when it gets to become many, many lines. So it's nice to use the CLI to interact with it. I can both create it and update it along the way as well. And so let me just show what this is. I say this is the entity or the table view or store procedure I want to show. It's going to be called series, but I'm pointed to the object. That's from the same syntax. It defaults to table, so I didn't have to say that. And then in GraphQL, which is not what we're going to show here, but in just a second we will, it's called series or series, a plural. The plural of series is series. And then it enables it in REST as well. And here are the permissions. Nice and simple. Hopefully this looks easy, because it is. I provide this to the container, and from that point forward, the engine takes it and builds everything for me, all the endpoints, the dynamic controllers, and everything else along those lines. Honestly, the way that you would have done it, with the same telemetry and introspection around the graph, all the resolvers, everything is built for you, and it's really, really great. Now, if I were to run this, the CLI command is simple, dab start. It reads the command, it reads the config file that's built in, automatically deploys it, gives you an endpoint and a port. My dynamic port was 5001. So if I click on this, it'll launch. I launched it in another window here, but I'll show you. It launches a browser, and that browser takes me to the root where it says that it's healthy, basically that everything is configured correctly. And then I say API/series, and it gives me the list of all of the series, just like you would expect, already serialized, brought back as JSON, with the ability then, by the way, to add things like you saw in OData, that I could add things like, let's see, select equals name. So that would be an example. And so let me change that back to equals. And it is series, select with a $, select name. And what it does is, $, select equals, lowercase select,
how you know
lowercase s and select. Thanks. And it brings back just the name. So, right, this allows you to do some basic projection of your data without having to change your endpoint and without having to change your database. So, Frank, I want to just give you this kind of starter endpoint and see what kind of application you can build for us.
Just before I show the little app I had, we had one question, and I wonder if you want to answer it right now. So I was asking, how do you manage the database schema change in DAP?
Well, so there's a hidden question inside that, I think. So when the schema changes, obviously you're going to change your configuration file to match it. But what you might really be asking is, how do you change the versioning of your application so that you handle the schema change without breaking your API endpoint? And that's one of the reasons we talked about APIM, or API Manager, being present. So that allows you to basically surface up the same API at 2 different endpoints, but allow you to change the payload as it goes in and out based on whatever version that you have. So versioning an API, that is a difficulty everybody who has an API has. If you change the schema in the database, obviously the API must follow along. If you point to a series table, but you change it to be shows, you're going to have to update it to do that. However, you could still alias that to make sure that the entities all have the same name, and the consumer of your API doesn't know that any changes made behind the scenes. However, if you want to change your API and version it, then you version it through API Manager so that you can have V1 and V2 and V whatever, or maybe based on date or some payload or header that you decide to do. All of that's handled by a manager for you. That's not what DAB does. Just like a minimal API or an API controller doesn't do that for you either, right? If you want to have version management, you use the tool for that rather than try and build a tool to do it for you. So I'm glad you interrupted me there, Frank, because that makes plenty of sense to answer. It's a common one.
Cool. So let's now switch quickly, just for 2 minutes on my screen. I created, previous session, I built like a Blazor WebAssembly, and I wanted to do something different. So I did a console app, right? So .NET
Nice.
New console, very basic. And here you can see the code. I did not do dependency injection or anything, but like I'm creating a client here. I'm using the same address, localhost, because I'm running, like you said, in a container. My database is a container. DAB is in a container for me. So like it's all on my machine right now because demo. And after that, I just do client, get me from a JSON async, and I specify here a type, a class, series list. We'll get where that come from in a second, because then the serialization will be happening automatically for me. So that's great. And here I specify where I want to go. So I won't try to type your query because you had enough issues typing it. But if I had some filters, I could just do the same as you did previously. I could move this part, the API, like in my base URL if I want. Like that doesn't make any difference right now. Obviously, in a real application, the connection will be in some configuration or something like that. And that's it. After that, we'll get the result and loop through to show the names. Now, where this series list is coming from, well, I'll just create, again, same page because it's a demo, but I created a class called series with public and name, because that's what if I go back to the schema, that's what I had, right? I know the ID was a number because there's no double quotes, and name was a string because there was a double quote. So I did something very simple. And if we look again, sorry, I switched too fast. It was in an array called value. And that's why I created here a series list. I would say, well, like that's a list. I could have say array, but list is just easier in .NET. So you have so many tools that I love. Series list, I mean. So I use this, say value, and it works. So now if I maximize my console and I do a .NET run, and I'm scared to do any typos, even just .NET run. Come on.
Lowercase s on select. Yeah.
And voila, I have all the Star Trek shows that are in the database.
Nice.
So
and you know what? Perfect. And it's good to show this as a console. For one, it takes away all the complexity of extra pieces around the edges. This is the sort of thing you might deploy if you're writing an Azure function and you need to reach out to an API to use some of that data. There's a lot of good ways to have such a basic implementation. It shows up a lot of places. So Frank, let's take it to the next level, though. So this is just a single table. Certainly, we can interact with multiple tables, multiple endpoints with DAB. Let's do that, but let's do it in the fanciest way we can. So let me jump back over into mine and make a small change. So the biggest change that I want to make is just, well, for one, let me just remind us what we have here. So if I go back into our diagram, so we just access the series table, but what I want to do now is show all the characters that are in each of those series. So if you think about the original Star Trek show, we have Captain Kirk and Spock and Bones and things along those lines. However, some of those characters, including like Spock, is also in another series as well. So multiple series. In order for us to do that in a regular database, we don't have a regular one-to-many relationship. We don't have a many-to-one relationship. We have a many-to-many relationship. And in order to accomplish that, we need a cross-reference table in between two tables. And that's what we have here with series underscore character, right? You can see it has as its compound key a series ID and the character ID. That allows for a character to show up in as many series as you want. Now, being able to do this in REST is actually super tricky. Not tricky, it's more painful than tricky, because it means we take series and we expose it as the series endpoint, and we also take series character and we expose that as the series character endpoint, and then finally, the character table, we expose that as the character endpoint. Doing that in REST means you'll call each of those at least one time. So you could start by getting all of your series like you demonstrated to us, Frank, And then you call and find all of the characters in that series, or maybe you just get the entire table back and do some joining in memory, and then go and get either individual characters that match those, or you use, or you get the entire thing back if you know that the character table isn't gigantic. However, one of these tables could have 1 million rows in it, 2 million, 10 million rows. It's a database meant to hold data, so it could be really big. So that's not really the best way to do it either. So we know we have $select that allows us to project down to whatever columns we actually want to return. We also have $filter that allows us to add a where clause, basically, so that we can make it so that we return only the rows we want. But even that seems a little brutal, because there's an easier way, and it's through GraphQL. And let me just kind of show how we would do GraphQL here. So let me start by stopping Dab, which is currently running. I'll back up to my my second demo, and I have another command here that I want to show. And this is the command line that I would run. So, but like we did before, I run the initialization and I add the series and character tables, but that's it. I don't add that cross-reference table because Dab doesn't require it. Instead, what I add now is an update command to series that says, I want to add a relationship called character. So this allows me to say series, character, and it brings back all of the characters that belong only to that series. And then I say the cardinality of this is going to be many to many, right? So I indicate that to be many. And I go through and say, which is the table? So this is my cross-reference table. We call it the linking object. And what the source and target fields are so that we can identify how to relate those together. What's beautiful, and one of the reasons we don't have to provide too much information here is because SQL already has foreign key constraints established inside the database. So Dab understands that. It's written by us. We're the SQL team. We know how to read SQL really well. And so we can make sure that this relationship is correct. Now, what's nice is, what if you don't have those constraints? What if you have two tables related together, but you've never set up their foreign key relationships inside SQL? That's no problem either. I can still set up the relationship in Dab here, just like this, and we will artificially, or kind of like behind the scenes, create it for you. Not by setting up a constraint inside your database, just by interacting with your data as if it were actually related. So a real neat capability allows you to give a real capable API on top of your data without having to change your database. All right, so let me just run this and just show what it looks like when we're done. And so in the second one here, let me just back out and show you that everything is still the same. I still have series here, but now I have a new property inside series called relationships. Of course, I can have more than one relationship if there were. This is the character relationship, and it's many to many, and goes through and basically just puts the JSON equivalent of what we put in the command line into the configuration file. So now when I say dab start inside the new folder that has the updated config file, now it starts Dab for me, and everything is still the same as before because this is additive. I've added on to what we had before. And so pulled over here. So let me just bring that down. So you can see it's healthy. And even though I know, well, let me just do it. So you can see API/series is still there. I can still get series, but I don't want to do that because this is the REST endpoint. Instead, I want to go to GraphQL and interact with the GraphQL endpoint. So because I'm in developer mode, it allows me to have Banana Cake Pop. So Banana Cake Pop, if you know what the Swagger UI is, and you think about what does the Swagger UI do for REST, it allows the developer to interact with it without having to use curl statements or anything else. That's what Banana Cake Pop is for GraphQL. It allows me to interact with it real easily. So look at one of the things I can do. I can write a query. This is the way a query looks like when I'm writing a GraphQL query. I can say query my series item name. So this is the same thing that I did before, right? So I'm running only the name. It's the same sort of projection where I pick what my properties are, or what my fields or columns are, depending on the backend database. And it brings it back exactly the same. So that part's beautiful and what I would hope to get. Now, because of the relationship now, I can say character. And character then has items. And those items are basically the fields or properties. And I can ask for the name of a character, right? And so I'll clean it up to look nice and pretty. I'll run it, and you can see each one pulls back Star Trek and the individual characters as well in a single payload. So instead of the multiple repeating calls that you would have had to have done in REST, now in Graph, you can build your own query against those and have the relationships pre-built and identified so that whoever is the consumer of your data API can get back what they need, and they aren't constantly beating up all of your endpoints because they need to get so much data and because REST can only give you so much, right? This isn't a full OData implementation on the REST side of Data API Builder. So instead, we have GraphQL. Remember, it's not a choice between the two. You can use them both depending on what your use case is. So there you go. I want to give this to you, Frank. Now you've got a graph endpoint that allows you to make just a single call to get lots of data related to one another.
Wonderful. So let's switch to my computer. I was planning to type a little bit. I'll try to speed it up a little bit. So I want to put some difference. So again, same thing here. I'm going to build like a console application because with Strawberry Shake, my favorite NuGet package of the day, there's 3 NuGet packages that you could use. So in the previous session, I was using Strawberry Cake Blazor because I was in Blazor. There's the .NET MAUI. But now, because I'm on a console application, I will be adding to my solution the Strawberry Shake server. So I do that. And then after that, there's 3 little commands that you need to use to be able to have the generated client, the GraphQL client, when you're using it, when you want to do GraphQL query. It's a mouthful. So first, you need to initialize saying .NET new tool manifest. That will create a config folder in your solution. And we'll show that in a few seconds. I just want to show all the command very clearly here. And after that, you install the tool, Strawberry Shake tool. Here, I decided to go local, so I don't pollute my computer, just that specific local folder. And after that, because right now I'm running against like a local database, like local API, I would say, sorry. I'm using localhost, but whatever is your database, you're setting your URL and say, hey, GraphQL init, and that will download the schema of your API. So now switching to the code, we recognize here a console application is mostly the same code that I did previously in Blazor. So I create a client here, just like this, getting the service from my library that was generated. I get the character by series, and then I loop through all of those. If I go back here, because I want to show a little bit more, let's go. If I expand the configuration, that's what the init tooling created. So it's installed the .NET GraphQL. I put my query here. I decided to put it in like a folder. I don't need to, but it's the same query that you were showing earlier, Jerry, in Banana Pup. I'm always his name. The configuration. So here I have the name of my client. I could have put a namespace if I wanted, and I have a schema that was downloaded with it. So with that, when I do my .NET build, it generates for me a client. And we say, where is the client? That's a big difference between Strawberry Shake version 12 and 13. And initially, I was struggling when building this demo because it was not reacting as before. That's why I want to spend time to explain it, is they change it to make it cleaner and everything. So if you're looking for your client, you won't see anymore the files there. But because it's built, if you go in the object in your .NET, I'm .NET 8, you have berries, and there it is. My client is here, so it's still generated for me. It's just now I don't specify output directory, and I won't be able to, well, like I could dig into it and like have fun with it, but like I won't see some output folder with the files. So if I run that again, should expect the same result in a less fancy way than Blazor, but I have all the series with the character.
Nice. All with a single call, so the API just does a single operation and builds the join statement back into SQL for you behind the scenes. That's really great.
So now, Jerry, I should get back to you so we could wrap up and not take too much time.
If you're a developer and you're looking at this, hopefully the light bulb has gone on and you're thinking to yourself, my code base can be considerably smaller now because I don't have to build so much of this repetitive code. I don't have to even have the unit tests. Think about your CI/CD pipeline and how much simpler your CI/CD pipeline is. And even more importantly, just think about how you can scale this now. And so everything is available to you. This is a free open source project that works with Postgres on-prem, works with SQL Server on-prem, in the cloud, MySQL, CosmosDB. It's really up to you, the backend database. And this is not only platform independent, but of course it's also language independent, because you're only interacting with an endpoint and only getting JSON back. This is a secure, feature-rich set of endpoints that you get for using this as well. And I just want to point out real quickly that this is an open source project, which means you're completely welcome to join us and contribute to it with us. And so that would be terrific. Here are some of the features that you get. We're about to go open. We're about to have. We're currently in preview. Will be generally available next month sometime, and so that's pretty exciting to see that on the horizon for us as well. It's been almost 3 years getting here. So much engineering behind the scenes that we've saved you from having to do as well. And so here's where you can get started at http://dab. And so there's a lot of resources that you can use and kind of go back into. We'll just leave the core ones for the event today, but also the ones specifically for DAB right here that you can go and use. So Frank, thanks for kind of walking through this, starting so simple and then starting to use more advanced endpoints so that we can have, honestly, an easier code base for our client as well.